Way before the AI tools we have today were even a thing, a massive 57-page patent application was filed, and it laid out this absolutely breathtaking plan. We're not just talking about making a smarter computer program here, we're talking about building a single, universal AI that could think, learn, and predict, just like a person. So today, we're going to crack open this forgotten blueprint from 2008.
Okay, so let's start with a really basic question. How do you know an AI is actually smart? I mean, how do you really test it? We've had benchmarks for decades, right? But what if we've been looking in all the wrong places?
Well, according to this wild patent from 2008, the answer isn't some complex board game like chess with all its strict rules and predictable moves. Nope. The true test, the ultimate arena for proving human-level intelligence, was something way more chaotic, creative, and unpredictable. A video game, like The Legend of Zelda.
And get this wasn't just some fun what-if scenario. This was the absolute core idea of a real US patent application. The thinking was, if you can build an AI that can actually master the crazy logic, the creative problem-solving, and even the language needed to beat a game like Zelda, well then you've built an AI that thinks on a human level.
So who was behind this? This whole vision came from an inventor named Mitchell Quoke, and he filed the patent for what he called the Human Artificial Intelligence Machine. This wasn't an AI designed to just do one thing. Oh no, this was a blueprint for a general all-purpose intelligence, the whole shebang.
The patent itself says this HAI program is basically a system that's meant to mirror the human brain, and its number one job above everything else is to predict the future. And no, we're not talking about a crystal ball here. It's about using memories of what's already happened to figure out what's going to happen next, which is exactly what you and I do every single second of every day without even thinking about it.
Okay, so this is the big question, right? How in the world was this thing supposed to work? How do you get a pile of code to have a conscious thought? Well, the patent actually breaks it down into a process that looks kind of simple on the surface, but is actually really powerful.
Okay, so picture this. The AI sees the world through its senses. The things it recognizes, like a person, a tree, a word, are called target objects. Now, for every one of those target objects, it has a bunch of associated ideas in its memory. Those are called element objects. So if the target is apple, the elements might be red, fruit, sweet, crunchy. And what's wild is, this sounds a lot like how modern AI uses things called embeddings to connect related ideas today. This was back in 2008.
So the whole process of consciousness gets boiled down to 5 steps. 1, it senses the world. 2, it figures out what it's looking at and pulls up every single related memory it has. 3 and 4, where it gets really cool. All those memories have a kind of mental battle royale, and only the strongest, most relevant one wins. And 5, that winning idea becomes its one single conscious thought. And that thought is what tells it what to do next. It's this non-stop, super fast cycle of see, remember, compete, act.
Let's make this real. The patent has this great little logic puzzle called the TV problem. So Jane tells Dave, no TV. Later, she comes home and Dave says, oh, I was just fixing the antenna. The AI sees 2 things, no TV and fix the antenna. Immediately, antenna connects to TV. But it also has this other rule in its memory. Fixing something means it was being used and it broke. So all those ideas compete, and the winning thought, the logical conclusion, is that Dave was watching TV and it broke. See, it's not just connecting words, it's making a logical leap. It's reasoning.
Okay, but wait, where do all these memories and rules even come from? You can't just type in everything the AI needs to know about the world, right? Of course not. The patent describes a learning process called bootstrapping, basically building its knowledge from the ground up.
It starts just like a person does, like a baby learning to walk. A human teacher literally guides the AI through simple things, creating these basic pathways in its memory. And here's the key. It associates success with a feeling of pleasure and failure with a feeling of pain. Good job? That's a pleasure signal. Mess up? That's a pain signal. Simple as that.
Then, after it learns the basics, it starts to get smarter. It learns to generalize. So this slide shows the AI taking what it knows about real-life baseball and applying it to a baseball video game. It figures out that a fastball means something different if you're the batter versus the catcher, and it can carry that logic from the real world into the digital one. That's a huge deal, right? Taking knowledge from one context and using it in a totally different one. And all of this training, it all builds up to this, getting the AI to a point where it can handle super complex, totally unsupervised stuff in the real world. I mean, think about driving a car. It's not just go forward, turn left.
It's spotting traffic lights, reading signs, dealing with other drivers. It's pure chaos. And that's the level of intelligence this system was aiming for.
But here's the kicker. All that stuff we just talked about, driving cars, playing video games, that was never the point. That was just the training ground. The real ambition, the whole reason for building this thing, was way, way bigger. It was all about using that intelligence to predict the future.
And to really get a feel for how deep this goes, just look at this. This is a real diagram from the patent. It's a full-blown strategic plan to beat The Legend of Zelda. I'm talking overall mission goals, specific tactics for each level, like which items to buy for a dark cave. It even gets into predicting the attack patterns of the bosses. So again, beating the game wasn't the goal was proving it could build a predictive model of an entire complex world.
And once it could do that, well, the inventor believed the sky was the limit. Actually, scratch that, the sky was just the beginning. The patent claims this one program could lead to AI operating systems, AI search engines, AI cars, AI planes, even AI vacuum cleaners. It suggests the AI could write its own software. And then it gets really wild, creating universal drugs to cure all diseases.
But all of that, even curing every disease known to man, wasn't the final boss. The ultimate, most mind-bending claim in this entire 57-page document is right here: predicting the actions of a human being. The idea was that the system would predict what a person is going to do next, by predicting the movement of their atoms, predicting what their senses are taking in, and ultimately predicting their thoughts. In a strange way, it's the logical endpoint. If your whole purpose is to predict, this is where you end up.
So what are we supposed to make of this incredible document from 2008? Was it just a wildly ambitious sci-fi vision that was decades ahead of its time? Or could it be a kind of forgotten map? One that lays out some really core ideas that we're only now, today, starting to truly explore in the world of AI? That's something to think about.